Hello again everybody, and well done for completing lesson 5.1, in which we looked at the way the solar wind can actually pose a threat to, in some rare cases, humans and ground-based equipment, space-based equipment, our modern technology, essentially. Now, on planet Earth, we are protected by our magnetosphere. Our magnetic field, as we saw in previous lessons, deflects most of the harmful solar wind. But if there were a spacewalking astronaut outside of Earth's protective magnetosphere, a big CME could cause them to suffer radiation poisoning and even threaten human life. In fact, in between the Apollo 16 and Apollo 17 missions, luckily there were no astronauts on the moon or travelling to and from the moon at this time. In between those two missions, there was a large CME, which, if there were any astronauts, could have posed life-threatening conditions and certainly severe radiation poisoning. So this is something that space agencies need to consider in the future. For example, if and when there is a human-operated mission to Mars, one thing that has to be considered is the solar wind during that journey. Also, if you move in a magnetic field around a wire, that accelerates electrons through that wire. When Earth's magnetic field is getting wobbled around by all of this solar wind, that's great for aurora chasers like me. We get to see the aurora, but it's not great for power networks. As Earth's magnetic field is molded and distorted, that wobbling effect accelerates electrons through ground-based equipment, and that can cause, and has caused, transformers to overheat and fail, causing blackouts, power shortages, and again, that can be very, very severe, some of the implications when it comes to leaving people in cold climates without power for days, weeks on end. So it's quite a serious implication, really. It's definitely something to consider. Also, satellites, low altitude satellites in particular, are at a risk. The ionosphere is heated when we have these big space weather events, and a hot ionosphere can cause low altitude satellites to lose atmosphere. The hotter ionosphere causes more drag, more friction on these satellites. They lose altitude and they can potentially fail. And also, higher altitude satellites can be damaged through electrical disruptions from the solar wind. So our satellites, GPS and whatnot, is also at risk when it comes to big space weather events. Solar flares can also cause radio blackouts. This can disrupt television, radio, GPS satellites, and even some aircraft flights. There are precautions we can take. Given fair warning, satellites can be put into safe mode, power grids can be disconnected, flights relying on radio alone can be cancelled. It's all about forecasting solar flares and coronal mass ejections to allow for this preparation time. Also, when they arrive, it's about monitoring geomagnetic storms. This gives power companies, for example, the information they need to make changes to the grid. Geomagnetic storms, they can be monitored with magnetometers based around the polar hemispheres. They can also be monitored with ultraviolet and visible cameras on spacecraft, like the beautiful footage here from the International Space Station, for example. So there's a quick summary of some of the threats posed by space weather and how humanity can prepare for the potential danger and also act upon it as well. And in the next lesson, what we're going to look at is one of the most extreme space weather events in recorded history and the implications that had at the time. So I'll see you again at the end of lesson 5.2. See you later.